We are at the PWN. We are a drinking water supply company in North Holland, which is in the Netherlands, and at the end of the river Rhine, and that's where we take our water from. So the Rhine is our main source for drinking water, and what we need is to foresee what is the quality and the quantity that is coming at us, and when can we expect salinization or deterioration of the water quality. Data is vital to do so. So here we have an example where we collect the data and transfer it to knowledge about our water quality in the coming weeks at least. We know there is a lot of data in the catchment area, but it's scattered. What we need is to combine the data, be sure of its quality, so validate the data, and process it such that it has insights for us as the drinking water company.
PWN as a utility face various legacy-related data challenges that include internal process data not available externally and vice versa. Datasets are in various formats, preventing interoperability, manual and intensive processes to conduct sound data curation, and in general, fear and mistrust over the origins and quality of crucial datasets. The WDME provides a technical solution as a centralized platform enabling efficient data curation, robust data management, and secure data exchange and utilization. In the Dutch pilot, various data sources, ranging from the National Weather Agency, the Ministry of Water Management, non-profit organizations, and PWN's internal data itself, are federated, with the collected data harmonized to standardized formats. The platform then facilitates the utilization of the combined datasets to gain additional insights and support the taking of operational and strategic actions. So, let us dive in and see some of the Dutch pilot use cases in action. Within the data preparation pipeline editor of the WDME, various data source connections can be federated. In this case, the data from the Dutch National Weather Agency is collected, and as you can see, the data follows the legacy format of the source organization. This data is then harmonized to a standardized format, namely NGSALD, where open-source data models, in this case weather observed, to describe the data, thereby increasing the interoperability and reusability of this data set. Similarly, another data source, in this case from Riwa Rhine, an association representing the Dutch drinking water companies that use the Rhine River as a water source, providing important water quality data on the concentration of various chemicals in the river, such as heavy metals and PFAS. In another functionality of the WDME, the data portal, the data collected and harmonized from the various sources are stored and organized within the PWN organization. Here, within a specific data resource, PWN's internal process automation data is also ingested regularly via an API endpoint, which was specifically developed to send data externally to the WDME. In contrast, the data portal also supports manual uploading of data files, which was conducted for the Riwa Rhine datasets. Here is also where the harmonized version of the dataset is stored and made available for further utilization. A key use case for the Dutch pilot is to gain predictive insights on the chloride concentrations of the Isolake water that is extracted for further treatment and delivery as drinking water to the citizens. For this, a machine learning model was trained to forecast the chloride concentrations for the next 8 days. These forecasts are used in a decision support tool that advises whether the intake valves should be kept open or closed, based on the anticipated chloride concentrations and available water in the reservoirs. The machine learning model uses various sources of data as input, such as the weather data, which were collected and harmonized as shown previously. Using the data preparation pipeline editor, the combined input data can be sent to the machine learning model, which is deployed in an external environment, in this case within PWN's own IT infrastructure. This application provides in return the chloride concentration forecasts and the advice on whether to open or close the inlet valve, based on the forecasts. This critical information is then stored back in the data portal to share with key stakeholders. Finally, the data and information in the Dutch pilot were visualized using DashRAM, the dashboarding tool of the WDME. Here, specific jobs were created to regularly send certain datasets from the data portal to DashRAM, where various charts were made, and to create automated reports for key stakeholders. The dashboards were tailor-made to the end user, such as operators and strategic advisors, and also depending on the information visualized, such as time series data or satellite-based image and analysis. The DashRAM dashboarding tool offers various chart-making options suited for diverse types of data. The WDME's capabilities and insights from this project have increased PWN's trust in sharing internal process automation data externally. Additionally, providing datasets that are now more fair accelerates the development of data-driven solutions to support operational and strategic decisions for isolate water management. Let's hear more directly from some of the key stakeholders.
The WATERVERSE platform for us is a way to combine all the data that is available. We know it's there, but here in the WATERVERSE platform, it's combined. We can check the reliability, validate the data, and even process it such that it's useful for us as a drinking water company.
What I notice is that data will be key for the future research we are doing, also in the field of water. I also therefore fully support the further development of the WATERVERSE water data ecosystem. I expect that by making available and sharing high quality and reliable data, we can shape our future research and in that way contribute to increasing the resilience of the water utilities.
So we've greatly benefited from the WATERVERSE project in the sense that we are able to take data that is already available but then in different systems and to basically make them our own and put them in a pipeline and also do an advanced analytics analysis on it to decide what are sources of contamination of the River Rhine.